So a quick walkthrough of these answers from my solution key. We have a function defined as an integral. They give us the graph of what we're integrating, which means we also have the graph of g prime. And to find g of 3, I'm simply going to take this function and replace all the x's with 3's, telling me to integrate from 2 to 3 this function. At this point, I'll interpret that integral as an area, and I'll find the area under the curve as x travels from 2 to 3. So I'm going to basically find this area. However you want to do that, feel free. Some people like to just go ahead and say this is a rectangle of area 2, this is a triangle whose area is 1, therefore the integral from 2 to 3 is 3, g of 3 is going to equal 3. To find g prime of 3, I recognize that f equals g prime. So the graph they gave me is g prime. That means finding g prime of 3 is the same as finding f of 3, which is finding the y value of this function when x equals 3. So I go to where x is 3. I find that point. Since f of 3 clearly equals 2 and f is g prime of 3 is going to equal 2. G double prime of 3 refers to the second derivative of g. Now, the evidence I have in front of my face is f, and I know f is g prime. And I also know the second derivative is the derivative of the derivative. So if f is going to equal g prime, then g double prime equals f prime. So what I really want to find when they ask me this, I'm going to investigate how to find f prime of 3. If I think back to first semester, the derivative is the slope. So I really want to find that slope at 3, and they told me these were straight line segments. So to find f prime of 3, I'm going to just investigate the slope of the straight line segment, which I can see is -2, which is how I get an answer g double prime of 3 equals -2. Good luck.